Hi everyone, and welcome to MathSux. This video is going to help you pass the Algebra 2 Common Core Regents. So here is question 36. The table below gives air pressures in kPa at selected altitudes above sea level measured in kilometers. Write an exponential regression that models these data rounding all values to the nearest thousand. So there's two parts to this question. Let's look at the first. We're going to be needing to use our calculator. So the first thing we're going to want to do is to go to Stat, Edit, Enter, and then we're going to enter in all these values. So the L1 will be X, and L2 will be Y. So let's just plug that in. So for X we have 0, 2, 3, 5. And then for Y values we have and I'm just getting that from looking at this. And it even says X, Y. So here we have L1, and here we have L2. So now we have all our data in our calculator, which is what we need. So now we're going to go to Stat, go over to Calc, and then we're going to scroll the way down or press 0 to exponential regression, because that's what they wanted, right? The exponential regression equation. So if we'll go here and then press Enter, and then we get all this information. So we have y equals a b to the x. That's our exponential regression function. And they tell us what to fill in. So for a, we have 101 point, and they wanted us to round it to the nearest thousand. 101 point, so that's 3 decimal places, 10th, 100,000. That's 3 decimal places. 5, 2, 3. So just rounding. B equals 0.883. And that's all we need from this, because now we can make our exponential regression function. So let's fill that in. So we have y equals a, 101.523 times b, 0.883 raised to the x. And that's our answer for the first part. So now the second part says, use this equation to algebraically determine the altitude to the nearest hundredth of a kilometer when the air pressure is 29 kPa. So notice the air pressure, it represents y, so that's what we're going to be filling in on our equation here. So if we have 29 is equal to 101.523 times 0.883 raised to the x. We're going to want to solve for x and then put it in the nearest hundredth, so the second decimal place this time. So let's just solve this. We're going to end up needing to use logs because we have this exponent right here. So let's divide both sides by 101.53. Okay, so when we do that, let's see what we get. We have 29 divided by 101.53. So let's just write all our decimals out so we make sure we get the right answer in the end. 0.285629861. And then we're left with 0.883 raised to the x. So now to get rid of this exponent, we don't know what it is. To find out what it is, we're going to do logs on both sides. So here we'll have log of 0.285629861, and then this will be equal to x log. Remember that exponent rule, where with logs, where there's an exponent, you can bring it down at the beginning. So we have log of 0.883. So now to find the value of x, we're just going to divide both sides by log of 0.883. And this will cancel out, and let's plug this into our calculator. So we have log 0.285. So this is equal to 10.07. So remember, they wanted the 100th place, 10th hundredth. We wanted that second decimal place, and we have it. And that's our answer. So this, don't forget to label this is in kilometers. So that's our answer. Need more practice? Check out MathSux.org for more questions. Link below. Also, don't forget to subscribe. Happy calculating!